Hello everyone, welcome back to my YouTube channel. In this video, let us discuss about EMF equation of transformer in a single phase transformer for basics as well as for second year students of EEE. So should derive this EMF equation, that is E1 or V1 equals 4.44 F5mN1 and E2 or V2 equals 4.44 F5mN2. So for this derivation, let us consider now the waveform. So we are discussing about single phase AC transformer so that we can consider sinusoidal waveform for one cycle. To complete one cycle, it takes time period of 1 by f, that is 1t. Similarly, to complete half cycle, it takes 2t. That is half of time period, that is t by 2. So that is nothing but 1 by 2f. Similarly, the amount of flux, here the y-axis represents flux, and the flux, whenever the flux it starts to produces from initial value, that is minimum, and it takes 1 by 4 times of time period to reach maximum value of flux. The flux which will be maximum at the time period of t by 4, that is 1 quarter time of time period, that is 1 by 4 times of t, that is nothing but 1 by 4f. So that let us initialize the notations. So let consider n1 is nothing but number of turns in primary winding, n2 is nothing but number of turns in secondary winding, phi m is nothing but maximum flux in the core in terms of Weber, and it is given by maximum flux density into area in terms of meter square, where Bm is maximum flux density in terms of Weber per meter square or Tesla, and A is area of cross section in terms of meter square or centimeter square, and frequency F is nothing but frequency of AC supply in terms of hertz. So now from this waveform we can observe the flux is increases from 0 to maximum value of flux phi m in 1/4 of the cycle, that is 1 by 4 times of t, that is 1 by 4 f seconds. Therefore, you define average rate of change of flux, that is rate of change of flux is nothing but d phi by dt, or defining d phi change of flux from minimum to maximum value, that is nothing but phi m minus 0 is nothing but phi m only, that is a change of flux from 0 to maximum value, and time taken to reach that maximum value of flux is 1 divided by 4 times of f. If you simplify this, you will get 4f into phi m. So now we are using the Faraday's law of electromagnetic induction. According to the Faraday's law, average rate of change of flux equals average induced EMF per turn. So that the average EMF induced per turn we already got, that is average EMF induced per turn is 4f/m. Therefore 4f/m volts is the average induced EMF per turn. So now I want just EMF induced per turn, we are sending into the right side, it becomes multiplied by turns. We'll discuss that later. Before that, it is the average value of EMF, but I want to get RMS value of induced EMF per turn, so that I am using form factor, which is defined by the ratio of RMS value of EMF induced to the average EMF induced per turn. So that I know the value of average EMF induced per turn, that is 4f/m, and form factor value I know, that is 1.11. Therefore, I can rewrite here 1.11 equals RMS value of EMF induced per turn divided by average EMF induced per turn is 4f/m. So you're just multiplying this 1.11 into 4, then you'll get RMS value of induced per turn. Therefore, the RMS value of EMF induced per turn equals 1.11 into 4 into f into phi m. So I can get 4.44 f into phi m. So per turn it is there. I just want RMS value of EMF induced, so that this per turn I'm sending right side, it becomes multiplied by turns, so that RMS value of EMF induced in primary winding, it denoted by 1. Therefore, for primary winding, it is E1 or V1 equals 4.44 F5M into N1. Similarly, for secondary winding, RMS value of EMF induced in secondary winding is given by E2 or V2 equals 4.44 F5M into. In general, the EMF equation of transformer is E equals 4.44 F5M N. For primary side it is N1, for secondary side it is N2 with respect to V1 and V2. And coming back to these basics, transformer ratios, voltage ratios, we know that E1 and E2 just now derived, that is 4.44 F5M N1 and 4.44 F5M N2. So for ideal transformer, you can take E1 by E2. You just divide this E2 by E1. You'll get E2 by E1 equals 4.44, 4.44. F5M will get cancelled. You can get E2 by E1 equals N2 by N1. We are calling that as a turns ratio. That is denoted by K. The ratio of secondary induced EMF to primary induced EMF is known as voltage transformation ratio. Therefore, you can write E2 equals K into E1 or else N2 equals K into N1. So you can write here that totally the turns ratio which is given by N2 by N1, that is equals to V2 by V1. You can see V2 by V1 equals K. That is nothing but V2 by V1 equals N2 by N1, that is equals I1 by I2. Okay, from current ratio it is. So if N2 is greater than N1, obviously V2 is greater than V1, we can call that as a step-up transformer. If N2 is less than N1, we can call that as a step-down transformer. If number of turns in a primary winding and secondary winding both are same, then we are calling that as a isolation transformer or ideal transformer. Also, you should know the full load current I is given by apparent power divided by V1. That is nothing but I1 equals S by V1. That is kVA rating divided by V1, and I2 is kVA rating divided by V2. So losses in transformer we'll discuss in next video. So if you like this video, do subscribe and share maximum. If you're having any doubts regarding this, feel free to write in the comment box. Thank you so much. Have a nice day.